there's only, I think there's 7 to fill and 6 to fill in with. I think one of them is the.
Maddie just got you that training commander back that thing.
Okay, so today we're finally going to finish up chapter 7, and then starting tomorrow we're going to move on to chapter 9, inheritance, which is one of the big ideas in object-oriented design. And the other little tidbit where we're a week from today, we're going to have a little midterm exam. Pardon me?
Just a little one?
Just a little one. It'll be in class, paper, and all that. And basically, one 8.5 by 11 gouge sheet you can put stuff on, so you don't have to memorize a bunch of stuff. So more on that will be forthcoming. But
Do you have an example?
yeah, I'll give you an example. But not right now. So it's just I left it in my other suit. So okay, yeah, interfaces. This is an idea that's not all languages have. This may be something that is a little bit new if you've only been using scripting languages and languages that don't have these things. And there's some debate as to whether they're really such a good thing. My experience has been that they are, and as they say on the internet, your mileage may vary. Nevertheless, if we're doing Java, then interfaces are an important thing. And then some stuff on enums, and that should do it for today. Okay, so the Java had a really nice implementation of the interface concept. The idea of the interface, it's a heavily overloaded word. You think of graphical user interface, that's the interface between the user and the computer. Any user interface or any interface is basically kind of the boundary between things. The idea of the interface is that you can specify what that interface is. That is, what methods you can invoke on a given object without having to specify exactly what they are. Without interfaces, you have to do both. Without interfaces, the interface of an object or the interface for a class that's defined in general are the public methods, the things that you can make the thing do, the things you can invoke on it. But with classes, with everything we've seen so far, you have to specify both the interface, which is the method name and its signature, as well as its implementation, that is what the method does. What the interface concept does, the interface property of Java, allows you to specify what that interface is, what those methods are, without having to specify exactly how they're implemented. So the abstract idea is kind of comes into play a little bit. Later in the course, we'll talk about abstract classes and abstract methods. But basically, an interface is one, and Java had this right the first time, and then they kind of mucked it up by adding, aren't you moving here? Why isn't my mouse working? Anyway, okay, so here's an example. So interface is a reserved word. When you type it in NetBeans, it shows up in blue. So what that means is you can't define a variable, a class, a method, or anything calling it an interface. are you? Try this. Okay. So here, this doable interface specifies 4 methods. There's do this, do that, do this too, and do the other. It specifies what the arguments are. In this case, do this and do that have 0 arguments. Do this too has a double and a character as its argument, and do the other has an int as its signature, and the return type. So it specifies the whole thing, but notice that there's a semicolon. Now let's try this again. All right. Okay, so instead of writing what these methods do, it simply specifies that this is what they are. This is what the methods that any class that implements this interface must implement. I like to think of it as a contract. So this interface, doable, is a contract, and if a class signs the contract, that is, if it implements this interface, then it must implement specifically each of these 4 methods. So if I have an object, and I know that it implements the doable interface, then I can, without fear of a compile error, I can invoke each of these 4 methods without regard for the compiler complaining. Now I could get a runtime exception if one of these methods, if I invoke a method and it throws an error. I mean, you can't, there's nothing to prevent that. But the compiler will let me invoke each of these methods. Okay, and you've all seen the red squiggly in NetBeans when you try to invoke a method that it doesn't understand. And so far, with classes, in order to make the red squiggly go away, the class actually has to have that method fully defined as the interface and implemented in the body. Okay, so an interface is, it's just a contract. It's just something that says these are the methods, and so you can't instantiate it. There's nothing to instantiate. See, because if this is all I have and I try to invoke this method, then what's it supposed to do? Haven't told it to do anything. Okay, they're all public by default, and in other words, an interface, even when we talk about it in the context of a class, the interface are the public methods. The private methods that might be helpers that we've talked about, those are not considered part of the interface because that's not something that another object can invoke. So you implement the interface by saying blah-de-blah implements in the definition. We'll see an example of that. And then you must provide an implementation for each of those methods. So that it's when you sign the contract. So you say, up to now we've just been saying, say public class, give it the name, and then now we add implements, in this case, doable. And so in order for the compiler to allow this, that means it checks to see, okay, you've claimed to implement the doable interface. Have you implemented every single method? So here, actually, in fact, it hasn't. Because it does do this, do that, and then there are 2 others. So, rather than list them all, it says, okay, presumably those are listed somewhere. Okay, but as it sits right now, the compiler would say, hey, you haven't implemented some of the methods in the interface. So this will give you a red, if not a red squiggly, red complaining. Okay, so now they added this constant thing. To me, that was a bad idea. I've never used that. There's a better way to define constants, as we've seen. But one of the Java started off as a really small and simple language that was object-oriented, and that was a big deal because all the object-oriented languages at the time, especially the predominant one, C++, was and is a very complex and difficult language. Okay, this is my opinion, but if you think Java is complex, then C++ is definitely not for you, because C++ is way out there. But then over time, as it gained popularity, people kind of kept asking for more and more features. Some of them were really good, and some of them were just good ideas. But nevertheless, the Java developers, in many cases, hopped on the good idea train, and that was an example of it. Okay, so, come on. Okay, so and these slides just kind of walk you through what the code is, so you can look at it either on the slides or in the class code as well. What's nice about the code is you can actually run it and see what happens, whereas in the slides you can't run it from the slide. Okay, what was the other thing that interfaces solved that was a bit problematic? And that we'll come back to this when we talk about inheritance. But basically, there was the idea is that you can have multiple interfaces. In other words, you can. There are situations where you want to have objects that have different interfaces, different facets, as it were. And again, we'll circle back to this. But we can implement as many interfaces as we want. When we start talking about inheritance, we can only inherit from one parent. So there's monosexual stuff going on. In other words, we can't have two parents. We can only have one parent. It's just the way it goes. But we can have multiple interfaces. Okay, so here's an example. One of the very useful interfaces that we'll come back to when we start talking more about the collections framework is the comparable interfaces. So when you have numbers, it's easy to see how you could compare two numbers. If I say which one is bigger than the other. So let's say I have a pile of numbers and I want to sort them from smallest to largest or largest to smallest. It's very easy to see how you would do that. You look at the number, see which one is bigger than the other. There are, good and not so good algorithms for doing that, but the concept is very straightforward. All you need to do is, if I have two of these things, can I decide which one is bigger than the other? That's all. That's really all you need. We've sort of peeked at it, but with strings, if you remember, the concept of which string is bigger than the other has to do with this lexicographic ordering, where all the capital letters come before all the lowercase letters, and all the numbers and things like that come before the uppercase letters. And so that's how you just like you would, if you were sorting something alphabetically, then that would be fairly straightforward. Lexicographic is like alphabetic, except the capitals and the lowercase ones. But now think about our friend the playing card. And if you're playing like a poker or something like that, unless you're at the high levels where you don't sort them, at the lower levels, you want to sort them and put all the different suits together, right? And maybe sort them smallest to largest. Certainly if you're playing a game like bridge, I don't know, you might have to ask your grandparents about that game. You know what the game of bridge is? You know, just you heard of it. So, again, at the pro level, they keep the cards all mixed up because you can tell, you can get information about what the card is from where they take it out if they've sorted them. But at the amateur level, you sort them, right? So what if we wanted to sort our playing card? Now the problem is that the way the class is defined currently, there is no way. Okay, so this is just we're talking about the comparable and then the iterator interface, which we've seen. The has next and next. We've seen that with scanner, and we've seen that with the iterator for array list. So we've seen a couple instances of that. Well, array list is one of the elements, one of the classes that are in the collections interface framework, and we'll see that every class in there can produce an iterator that we can step through things. And how it iterates through. In the array list, it went through by index, but we will see things like sorted sets where it will iterate through according to the comparable interface. We will see that. And then there's the iterable interface, which says, if you implement the iterable interface, then you can provide an iterator through a method called iterator. And we've seen that in the array list. But we haven't commented on the iterable part. So the iterable interface says, if you implement that, then you must implement the iterator method. The iterator method will return an iterator, which will allow you to step through that collection. Okay, so interfaces are good. And well, that's an opinion. Interfaces are things that you're responsible for. So whether you like them or not, that's just what it is. And you might be thinking, why? You might, hopefully you have some sense of the why. In order to understand the why, you need to see situations where you can have many different classes which implement the same interface. We've seen really only one example of that, and that is the scanner and the array list. Both implement the iterable interface, scanner implements the iterator interface. The array list could return an iterator, as we saw, which implements the iterator interface. And the scanners had next and has next, as well as a bunch of other things. But those two methods were specified by the iterator interface. The iterator we got from the array list, again, specified those two methods that allow us to step through them. Okay, enumerated types, and this is something that we can do with enumerated types that we hadn't seen before. So we've seen examples like season. We've seen our example in the card with the suits and the values, and we can use those to declare variables. So in a way, it's a special kind of class, and the values are a special kind of class variable. And in fact, before Java introduced enums, see what happened was that there was a pattern that you would have to use where you would have to do a lot of the stuff that enums do by hand. But it was just kind of catch as cat, it was a little subject to the user fallibility. And at some point, this pattern was used so much, and this enum concept was so valuable that Java decided, okay, we'll put it in. This is one of the cases where the user's demand for a particular feature was actually a good thing. So again, we've seen this with the suits and the values for these playing cards that you may be sick of it already. But it turns out we can do a little bit more with enumerated types. So we can define instance variables and constructors, and their example is not quite as interesting as the one I'm going to show you in a second. But here's how, it's a little bit odd how you do it. So what you, and when you're defining these, you have to kind of push through a bunch of red squigglies, which is one of the things I don't like about it, but nevertheless, that's what it is. So here, their season thing, they said, okay, in addition to season, we're going to have a string that says what months this season has. Okay, so what we do is instead of just plain old winter, we now have winter and then give it a string. Now, how does it know to handle that? Well, because there's a constructor. The constructor is right here. Now, unlike a class, though, we cannot define the constructor to be public. Now, there are actually two options. We could define it with the default visibility, which they've done here, or you can define it with private visibility, which is my personal preference. So this is yet another place where I just have a different approach than the book, but that's okay. And then, so here in their little example, we just sort of print them all out. And as we've seen, it has a static method called values that returns an array of all the different possible types. As we saw in the suits and the values, it also has a method called ordinal, which for a particular enum, which returns basically the index in that array. Okay, so my one last